Hello everyone! This video will be on the 3.2 section of the IB/AA curriculum. It is going to be a review for a lot of you from grade 10 math and grade 11 math, so if you need to review some concepts, please take some time to do that on your own. Please pause the video for a second to look at the concepts, contents, and formulae for this section. One sentence that summarizes the section is, use trigonometric ratios and rules to solve a triangle. Let's start with the right angle triangles. We all remember how to solve a triangle in this case, using the sides and angles, right? By the way, to solve a triangle means that we find all the angles and sides of the triangle. We start by identifying the angle that we want to focus on. For example, we have a right angle triangle like this. We identify the angle that we want to focus on. Let's label as theta, and label the sides according to it. The opposite, adjacent, and hypotenuse. Then we can identify the primary trig ratios, the sine, cosine, and tangent, using the popular mnemonic SOHCAHTOA wa. Theta be so opposite of hypotenuse, so op or hypotenuse. Cosine would be adjacent or hypotenuse. Tangent theta will be opposite or adjacent. It is important that we identify which information do I have and which information do I want. Let's say I have an angle and an adjacent, and I want the hypotenuse. Then we want something that has theta, a, and h, which is cosine. Thus, we use the cosine ratio to find the hypotenuse. Together with the Pythagorean theorem, we can solve any right angle triangles. Well, that was easy, especially because we were dealing with the right angle triangles. But what if we're trying to solve non-right angle triangles? Are we forever doomed? Well, this section is just there to help you out. The formula that you see here, they're for solving non-right angle triangles. Let's say that we have a triangle with vertices A, B, and C. And by the way, by convention, we usually label the vertices with the uppercase letters, and the opposite side is labeled with the lowercase letters. For example, triangle, the opposite side will be lower c. And opposite side of the vertex B is lower b, and so on. The first rule, the sine rule, tells us the ratio of a sine of an angle, and the opposite side is the same for all three angles and sides. Let's say that we have a triangle like this. A equals 30 degrees, and opposite side, A is 5, and B is 7. And we can use the sine rule to find the angle B. For example, using the formula, let's do it that way. And by the way, if you make a mistake like this, it doesn't matter too much. It still gives the same value. Okay. And then I know small a, which is 5. I know big A, sine 30, equals B is 7, sine. And then we can solve for sine B by isolating it. Sine 30, we can make a triangle like this, 30 degrees, and the sides are 1, 3, and 2. So sine 30 would be opposite over hypotenuse, so 1 over 2. I know that sine 30 is 1 over 2. And we know that this is equal to 7 over 10. And then, because we know that sine B is 7 over 10. And so find b as arc sine 7 over 10. Right. The next rule is called cosine rule, and it is used when we know more about the sides than angles, especially when you're given the angle contained by two sides. Let's say that we have a triangle like this where A is, or C is 60 degrees. Sorry. Right. A is 60 degrees, and small a. We know the sides B and C, and we can look for the value of small a using the cosine rule. Cosine rule looks like that. C squared equals a squared plus b squared minus 2ab cos c. And notice that we can just change the letters in the way that we're interested. Okay, so I'm going to put a squared equals, say, b squared c squared minus 2bc cos a. B is 8, C is 5, uh, 64 plus 25 minus 2 times 8 times 5 is 16 times 5, it's 80, and cos 60, the triangle, that's 1 over 3 over 2, so cos 60 is 1 over 2. 64 plus 25 is 89 minus 80 times 1/2 is 40, it's 49. I know because a squared is 49, it has to be 7. Lastly, there is a general formula for finding the area of a triangle. Half of AB sine C. Let's try to find the area of an example that we just did. So, area is given as 1 over 2 AB sine C, but let's just change the names. It's going to be BC and sine A. Let's just say it's area. I know that's B is 8, C is 5, and sine A was sine 60, and sine 60 in this case would be opposite of hypotenuse, so that would be square root 3 over 2. And then we can solve everything. 10. Right? If you're given two sides and an angle, not the height, you can use the formula here to quickly find the area. There's no immediate algorithm to determine which rule to use. It depends on the context, and it depends on your comfortability. Remember to identify which information you have and which information you need to determine which rule to use. Labeling and creating a table will help to organize your information. Also, if you're in HL or if you're interested in proving, trying to derive the formulae of both might be a useful idea. I hope you enjoyed this video and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.